हेलो स्टूडेंट्स, गुड इवनिंग टू ऑल ऑफ यू। सो हमारा आज का टॉपिक है रिफ्रैक्शन, रिफ्रैक्टिव इंडेक्स एंड स्नेल्स लॉ। तो हम आज इन टॉपिक्स के बारे में अंडरस्टैंड करेंगे। सो फर्स्ट आई एम जस्ट स्टार्टिंग फ्रॉम द रिफ्रैक्शन। सो लाइक व्हाट इज रिफ्रैक्शन? सो इट इज phenomenon of yeah it is the phenomenon in which there is a change in path of light, in which there is change in path of light when its medium changes. So it means that when light enters from one medium to some another medium, its direction or its path will change. So that is known as the refraction. So ये कुछ इस तरह से है. Let's suppose this is air and let's suppose this is water. So this is one medium, that is air is one of the medium and water is also one of the medium. So this is our incident ray, this is our incident ray, and this angle is I, angle of incidence. Then we just extend this normal there. So now there is a change in the path of light. So this angle, that is refracted ray, not reflected, this is refracted ray. So the refracted ray make with the normal is the angle of refraction. So light is coming along this path, but it get refracted on change of medium. So that phenomenon is called as the refraction. तो इसे हम refraction कहते हैं. सो ये रिफ्रैक्शन जो है वो कितना होगा लाइट, जब आप लाइट अपना एक मीडियम चेंज करेगी, सो किस एक्सटेंट तक हमारे पास रिफ्रैक्शन होगा, वो हमें पता चलता है एक मटेरियल की करेक्टरिस्टिक प्रॉपर्टी से, जिसे हम रिफ्रैक्टिव इंडेक्स कहते हैं. सो फर्स्ट वी जस्ट डिस्कस दैट रिफ्रैक्शन. सो इट इज अ फिनोमिनन इन विच चेंज इन पाथ ऑफ अ लाइट when it just changes its medium. So this is medium 1 and this is medium 2. Light is changing its medium, so it get refracted. There is some change in its direction of propagation. So the extent of this propagation depends on a property that is known as the refractive index. So now let's discuss about the refractive index. Refractive index. अब ये जो refractive index है, it is just a number there, it has no units. That refractive index tells us about the, or give us information that to what extent there is refraction there. किसी मीडियम में कितना रिफ्रैक्शन हो रहा है, ये हम उसके रिफ्रैक्टिव इंडेक्स से किसी दूसरे मीडियम के रिस्पेक्ट में पता लगा सकते हैं. जैसे मान लीजिए कि अगर आपके पास एक मीडियम का रिफ्रैक्टिव इंडेक्स लेट सपोज 5 है, एक मीडियम का रिफ्रैक्टिव इंडेक्स मान लीजिए 3 है. So the medium that is having refractive index of 5 is considered as the denser medium, or we can call it as optically denser medium, and it is called as the rarer medium. Means जिसका refractive index 5 है, it is more denser in comparison to the medium जिसका refractive index 3 है. So refractive index give us information or tells us about the extent of refraction when light enters in one medium from the other one. So refractive index हमारे पास, हम दो तरह के refractive index की यहाँ बात करेंगे. One is simply called as the absolute refractive index. Absolute refractive index. So absolute refractive index को represent करते हैं small n से, and it is just the ratio of speed of light in vacuum upon speed of light in that medium. So this ratio is known as the absolute refractive index. Absolute refractive index is ratio of speed of light in vacuum to the speed of light in medium. This is called simply absolute refractive index. And then other one we have, that is called relative refractive index. Relative refractive index. So in this relative refractive index, like we are talking about refractive index of one medium with respect to some other medium. So that is called relative refractive index. तो फॉर एग्जाम्पल मैं अगर दो मीडियम्स के रिफ्रैक्टिव इंडेक्स को रिलेट करता हूँ, फॉर एग्जाम्पल आई टेक अ मीडियम वाटर एंड अदर मीडियम इज लेट सपोज ग्लास. तो मैं दो मीडियम्स कंसीडर कर लेता हूँ, एक वाटर और एक ग्लास. सो मान लीजिए मुझे फाइंड आउट करना है रिलेटिव रिफ्रैक्टिव इंडेक्स. सो आई विल find out like that. This is the representation जी म्यू डब्ल्यू। ये जो मैंने यहाँ पर इस तरह से जो लिखा है, जो रिप्रेजेंटेशन दिया है, दैट इज रिप्रेजेंटिंग द रिफ्रैक्टिव इंडेक्स ऑफ वाटर with respect to glass. This is called relative refractive index. Means it is refractive index of water with respect to glass. This is G mu W. It is represented like that. For example, अगर मैं ऐसे लिखता W mu G, it means that it is the refractive index of glass with respect to water. So how we find out that relative refractive index? For example, मुझे find out करना है G mu W, means I have to find out refractive index of water with respect to glass. तो इसका relation है mu water upon mu glass. Mu water का मतलब है refractive index of water and mu glass का मतलब है refractive index of glass. This is how we can find out the relative refractive index of a medium with respect to some other medium. यहाँ बात कर रहे हैं water का refractive index with respect to glass. So you can find using this formula, that is mu w upon mu g. एंड हमारे पास हम म्यू का एक्सप्रेशन भी लिख सकते हैं. दिस इज द रिफ्रैक्टिव इंडेक्स ऑफ वाटर. सो हमने ऊपर एक रिलेशन लिखा है फॉर दैट एब्सोल्यूट रिफ्रैक्टिव इंडेक्स, तो इसका यूज भी हम यहाँ कर सकते हैं. सो म्यू वाटर का रिलेशन लिखा जाएगा लाइक स्पीड ऑफ लाइट इन वैक्यूम, दैट इज सी, यानी कि 3 × 10⁸ अपॉन स्पीड ऑफ लाइट इन वाटर. Similarly, for that mu g, we can write speed of light in vacuum upon the speed of light in glass. सो नाउ हम इसको थोड़ा सिंप्लीफाई कर लेंगे, सी से सी कैंसिल हो जाएगा एंड वी हैव वेलोसिटी इन ग्लास या स्पीड इन ग्लास और स्पीड इन वाटर. सो दिस इज ऑल्सो द रिलेशन दैट गिव्स यू नॉलेज अबाउट द जी म्यू डब्ल्यू, यानी कि रिफ्रैक्टिव इंडेक्स ऑफ वाटर विद रिस्पेक्ट टू ग्लास. और सिंपल अगर एक और एग्जांपल लेके समझ लेते हैं. फॉर एग्जांपल आई हैव टू मीडियम्स, लाइक वन इज ए अदर वन इज बी, सो इट इज रिटन एज ए म्यू बी. इसका मतलब है बी का रिफ्रैक्टिव इंडेक्स ए के रिस्पेक्ट में, सो इट इज रिटन एज म्यू बी अपॉन म्यू ए. यहाँ से हम इसे निकाल सकते हैं और इट इज इक्वल टू वेलोसिटी ए अपॉन वेलोसिटी बी. सो वी ए अपॉन वी बी. इस फॉर्म में भी हम इसको कर सकते हैं और रिफ्रैक्टिव इंडेक्स की टर्म्स में भी हम रिलेटिव रिफ्रैक्टिव इंडेक्स को फाइंड आउट कर सकते हैं. So this is about the refractive index. So refractive index is a characteristic property of a medium. So various mediums have different atomic arrangement, different optical densities. So on that basis they have different refractive index. So they different behavior से वो different refract करते हैं light को. So like more the refractive index of a medium with respect to the another medium, it means that that medium is more denser in comparison to the other one. सो फॉर एग्जाम्पल लाइक जो वाटर है उसका जो अपना रिफ्रैक्टिव इंडेक्स है, इट इज़ 1.33 एट नॉर्मल 20 डिग्री सेंटीग्रेड टेम्परेचर. एंड फॉर एग्जाम्पल वी हैव अदर वन लाइक डायमंड का जो रिफ्रैक्टिव इंडेक्स है, इट इज़ अप्रॉक्सीमेटली 2.42. So it has no units, it just index, it is just a number. So it tells you about that what is the extent of refraction when light enters in one medium from that other one. So in this case, like we have two examples of water and diamond, it means that diamond is more denser, optically denser in comparison to the water. So light refract in a medium depending on the refractive index of that medium or material. So now let's come to the Snell's law. That is very important law, and on the basis of this law we can solve many problems there. So let's derive that expression for Snell's law. What is the statement of Snell's law? This is Snell's law, and it is very important law when we talk about the refraction. So for example, we have two mediums. Again, I take one medium as let's suppose it is air, and let's suppose it is water. So for example, light is incident there, and this is angle of incidence, this is I, and this is the refraction. As air has a refractive index approximately 1, and water we know that it is 1.33. So water is more denser, this is the denser medium, and this is the denser with respect to the air. So air is the rarer medium there. So when a light comes from a rarer medium to a denser medium, it basically bends towards the normal. For example, अगर ये लाइट में लाइक कोई मीडियम चेंज नहीं होता, सो लाइट जस्ट गोज लाइक दैट, इसने सीधे ऐसे निकलना था, बट देर इज अ चेंज ऑफ मीडियम एंड इट इज कमिंग फ्रॉम अ रेयर टू अ डेंसर, सो इट बेंड्स टुवर्ड्स द नॉर्मल, लाइक ये ऐसे नहीं जाएगी, नॉर्मल की तरफ बेंड करेगी, इट मीन्स इट इज लाइक दैट. So now this is the angle of refraction. So the bending of light is basically due to the interaction of the electric vector of that light with the material there. Because light is electromagnetic wave, so it is basically the interaction of electric vector of that electric oscillation of that light with the material. So different materials have different composition, means a different atomic makeup, so they reflect the light differently, and वही चीज उनके refractive index में भी झलकती है. Like more is the refractive index, more is the extent of refraction there. So light is coming from that rarer to the denser medium, so that this is I, this is R. So now we have to apply the Snell's law. Yeah, what is the statement of Snell's law there? So according to Snell's law, that refractive index mu and into sine of angle of incidence, product is always a constant. Let's suppose that angle of incidence is I, so we have to take sine I multiplied with the refractive index of that medium, so that product is always a constant. So that is the statement of Snell's law. And now we apply that Snell's law on this refraction there. So जहाँ पर भी refraction होगा जिस भी problem में, you apply that Snell's law and create some equation like that. So now in this case we also apply that to understand that how we apply that Snell's law. So in this case we take air as one of the medium and water as the second medium. So this is like, let's suppose mu a is a refractive index of air, so I write mu a, and angle of incidence is I, so it is written as sine I, and it should be equal to a constant. And on the other side we also apply on the second side there, so it is written as mu water, यहाँ का refractive index है water का, mu w let's suppose, and angle of refraction is R, so it is written as sine R. So that is the utilization of Snell's law on a one refraction. This is the refraction there, so we apply the Snell's law, that product is always a constant. So mu air, the refractive index is a, mu a, angle of incidence is I, so it is written as sine I, so that product is constant. That is known as the Snell's law. It is one of the most important law in the refraction, so you can write it as a sine I upon sine R is equal to mu w upon mu air. So you know that you can write that mu w upon mu a means refractive index of water with respect to the air. So it is written as a mu w, or we can write it as velocity in air upon velocity in water. So this is the utilization of Snell's law in case of refraction. So these are some of the important uh, points or important definitions about that refraction, refractive index, and Snell's law. So you have to apply Snell's law in various cases like that, जैसे हमने यहाँ पर इस्तेमाल किया है. अब various जगहों पे Snell's law का इस तरह से utilization करेंगे. So I just hope this is clear to all of you. With that, thank you very much.